All right, starting lesson 5.3b. All right, and in this lesson, we begin to work with trigonometric equations that are of the quadratic type. All right, so here's an example of that here. All right, and just imagine you replaced the sine squared x with x squared. Sine x with x. All right, so you're just replacing the sine x with an x, and you have a quadratic type equation. All right, and I approach the problem the same way as if it was a normal quadratic. So starting off with example 1, you have 2 sine squared x minus 3 sine x plus 1 equals 0 in the interval 0 to 2 pi. I'll get to this at the very end. Okay, so just imagine you're dealing with this type of equation. What would you do? All right, you're going to have to use the big X with grouping method, or at least that's what I teach. If you have your own method, go ahead and do that. All right, but I need to find two numbers that add up to -3 and multiply to give me 2 times 1, 2. All right, and those two numbers will be -1 and -2. All right, so I take the first term as is. The second term I break up using these two values. So I have negative sine x minus 2 sine x plus 1 equals 0. All right, I'm going to group the first two, group the last two. All right, so out of the first group, I could pull out a sine of x, leave me with 2 sine of x minus 1. Out of the second group, I could pull out a -1, leaving me with 2 sine of x minus 1. All right, and from the two terms now, what do they share in common? They share in common 2 sine of x minus 1. And then what am I left with? I'm left with sine of x minus 1. All right, it's factored now. So let's solve the equation by setting each factor equal to 0. So I have 2 sine of x minus 1 equals 0. And I have sine of x minus 1 equals 0. So I add 1, and I have 2 sine of x is equal to 1. So I have sine of x is equal to 1/2. And here I add 1. I have sine of x is equal to 1. All right, and 1 is the same thing as 1 over 1. So sine is opposite over hypotenuse, and hypotenuse is always positive. So opposite in this case must be positive. So I'm going to create some triangles. And what quadrants is opposite positive? Okay, and when you're working with sine, you work in all 4 quadrants. All right, quadrants 1 and 2. All right, opposite is 1, hypotenuse is 2. This must be square root of 3 then. And this has to be 30 degrees then. All right, and let's see, what are our answers here? All right, so now I just need to figure out the rotation for this terminal side. That's 30 degrees, or pi over 6 radians. All right, then you have this rotation here, which is 150 degrees, which is 5 pi over 6 radians. All right, then I have this equation over here. Let's build some triangles. Okay, now here I have the hypotenuse, opposite, that's positive, positive. Okay, now the opposite and the hypotenuse are the same. Where does that happen? That's when the terminal side lands on the positive y-axis. All right, so what's my rotation here? My rotation is 90 degrees, or pi over 2. All right, so once again, just refresh your memory. The adjacent here is 0, the opposite here is 1, and the hypotenuse here is 1. Okay, now, why do I not add 2 pi n in this problem? Because in the directions, they said, just find the solutions within this interval, 0 to 2 pi. All right, 0 to 2 pi is starting here and going all the way around. And we did that. We found all the solutions within that restriction. And that's all I'm concerned about. So we're not adding on 2 pi n. I'm not looking for every single solution. I'm just looking for the solutions from 0 to 2 pi. All right, that's all there is. Okay, for example 2, you'll notice that we're starting with 2 trig functions. Now it's always more simple when you could get just one trig function. So what are we going to do here? Well, secant squared, if you apply the Pythagorean identity, it's equivalent to 1 plus tangent squared. Okay, and I have minus 2 tangent squared x minus 4 equals 0. All right, let's simplify this. Okay, and then combine like terms here. So I have tangent squared x minus 1 is equal to 0. All right, so here I'll add 1. I have tangent squared of x is equal to 1. Then I take the square root. Don't forget the positive and the negative. And I have tangent of x is equal to positive negative 1 over 1. Okay, now tangent is opposite over adjacent. All right, now recall that when you're working with tangent, you're only working in quadrants 1 and 2. Okay, so let's see, we have positive when are opposite and adjacent both positive. That's quadrant 1. All right, and they could also both be negative, and you'll get positive. That would be quadrant 3, but you're not working in quadrant 3. All right, let's work with the negative case now. Now you could have opposite is negative and adjacent's positive. That would be quadrant 4. Can't work there. But you could also have opposite is positive and adjacent is negative. So that would be quadrant 2. All right, and we have opposite, adjacent, opposite, adjacent. All right, and since these side lengths are the same, that means we're working with 45, 45, 90 triangles. Once again, that's the square root of 2 for the hypotenuse. All right, so what's my rotation? It's 45 degrees, or in radians, it's pi over 4. Then I have 135 degrees, which is 3 pi over 4. Alrighty. And since I'm working with tangent now, I'm adding on pi n. And this time I added on pi n because there was no restriction. Unlike before, it said go from 0 to 2 pi. But here they're asking for all of the solutions. All right, so there's our solution. Done. Okay, for this type of problem, we have sine and we have cosine, but they're not squared. Okay, so how else are we going to relate sine and cosine if we can't apply the Pythagorean identity? Well, we can't. So that's why we introduce a square into the problem. And by doing that, I will eventually be able to apply the Pythagorean identity. All right, so I have sine squared of x plus 2 sine of x plus 1 equals cosine squared x. Alrighty, and now I want to have the same trig function, so I'll just apply the Pythagorean identity to the cosine squared x, and I'll replace it with 1 minus sine squared x. Okay, and then I'm just going to bring all the terms over. Minus 1, here I'll add sine squared of x as well. Okay, so I end up with 2 sine squared x plus 2 sine x. That's equal to 0. Then we have 2 sine of x. Then I have sine of x plus 1 is equal to 0. Okay, so now I can do a little work on the side here. Set both of my factors equal to 0. Sine of x is equal to 0. Okay. All right, sine of x is equal to 0. So this is opposite over hypotenuse. Hypotenuse is always positive. In this case, my opposite is 0. So when is opposite 0? All right, recall how I used to make these triangles here. All right, as the triangle collapses, goes down, what's happening to the opposite? It's getting smaller and smaller, right? So when it lands on the positive x-axis, opposite 0. But when it also lands on the negative x-axis, opposite's also 0. So your rotation is 0 for one of them, and it's 180 degrees, or pi, for the other. All right, now for sine of x is equal to -1, you have opposite over hypotenuse. Hypotenuse is always positive, so opposite's negative. All right, and when do we get 1, or -1 over 1? So that means that your opposite is -1, and the hypotenuse is 1, so your adjacent must be 0. We're in quadrant, we're not in any quadrant, we're on the negative y-axis. All right, so your rotation here is 270 degrees, which is 3 pi over 2. Okay, if you have trouble understanding this, this is actually a very, very simple concept once you understand it. If you need any clarification, please make sure to ask for help. All right, but after we find these answers, since we introduced a square into the problem, whenever you introduce a square, all right, into an equation, there's a possibility that you're introducing extraneous solutions. So we have to check all our answers to make sure that they actually work. All right, so let's go ahead and do that. Okay, so checking our answers, we're going to check this one. Sine of 0 plus 1 equals cosine of 0. Okay, so if my rotation is 0, my terminal side is right here, and I have opposite, which is 0. My adjacent will be 1, and my hypotenuse will be 1. So checking my answer here, I'll have 0 over 1 for sine, and then I have just plus 1, and that's equal to 1 over 1. Is that true? Yes, it is. All right, so that answer works. Now I'm going to test pi. So I have sine of pi plus 1 is equal to cosine of pi. All right, make a little diagram here. If my rotation is pi, this is where my terminal side lands, and my opposite will be 0. My adjacent will be -1. My hypotenuse will be 1. All right, so sine is 0 over 1 plus 1, and cosine is -1 over 1. So I end up with 1 equals -1. That is false. So this is not an answer. This is not a solution. And then for the next one, I have sine of 3 pi over 2 plus 1 is equal to cosine of 3 pi over 2. All right, drawing a diagram for that, I have this. Rotate 3 pi over 2. Okay. And I have adjacent, opposite, hypotenuse. My opposite will be 1, adjacent 0. Actually, opposite's -1. -1. And hypotenuse is 1. So plugging in my values for my trig functions, or obtaining the proper ratio, I get -1 over 1 plus 1, and cosine of 3 pi over 2 is 0 over 1. So from that I get 0 equals 0. That checks off to be true. Okay, so from the 3 answers that I ended up with, only 2 of them are actual answers after checking if they're extraneous or not. So here's your solution. X equals 0 and x equals 3 pi over 2. Okay, let's do one last example. Okay, first thing I need to do is isolate the trig function. So I'll add this on both sides. Alright, so sine of 2x. Alright, now you haven't seen anything like this before. So what do you do in this situation? Alright, well here I have opposite over hypotenuse. Hypotenuse is always positive, so opposite must be positive. And that means you're working in which quadrants? Well, if opposite's positive, you're working in quadrants 1 and 2. You may still be asking, hey, what about this 2 here? What am I supposed to do with it? You don't do anything. All right, we'll get to that at the very end. All right, so here I have, is that right? Square root of 2? Square root of 3. Cut myself. Okay, so here I have square root of 3. Here I have square root of 3, 2, 2. Right away you should notice that these are 30, 60, 90 triangles. That's 1, negative 1, so that's 60 degrees. All right, that's your 30. Okay, now I'm concerned about my rotation. All right, so 60 degrees is pi over 3. And I'm going to rotate 120 degrees, and that's 2 pi over 3. Alrighty, and then I'm going to add 2 pi n to these solutions because I want all of my solutions. Alright, now for this problem, we've done everything correct so far except for one piece. We have to take into account this 2 here. So normally you set, if this was sine of x, then you have x here, x equals whatever you come up with. But now we have 2x. So instead of saying x equals, we're going to write 2x equals. Alright, and because we have 2x and we want to isolate x, we divide by 2 then. Alright, divide it into both parts, and we'll get x is equal to pi over 6 plus pi n. And we'll get 2 pi over 6, or 2 pi over 6 is the same thing as pi over 3 plus pi n. Alright, and that's our solution. Alright, so for this type of problem, what you have to watch out for is the 2x. Alright, so just treat it, to start off with, as if there was a sine x there. So go through the whole problem, do everything the way you normally do it, and at the end, take into account the 2x. So instead of writing x here, you write 2x, just divide by 2, and boom, you have your answer. So not much more to it. If you have any questions, please make sure to ask. Begin the assignment at the bottom of the page.